Okay, so we are going to we're going to find and create a residual plot based on this data, um, and we're also going to um, find the standard deviation off the least squared regression line for this data. So if you need to, pause this video and go ahead and type in all the information that you need. Okay, so if you have all your data entered into list 1 and list 2 for x and y, it's very easy to go and find a least squared regression line. We're just going to go to stat, we're going to go over to calculate, and we're going to go down to linear regression ax plus b. So um, your calculator may look a little different, but your x is going to be list 1, your y is going to be list 2, and is also going to be very good to go ahead and store this information into y1. So the way that you do this automatically is go to this vars key. It's right below the down key. Hit that. You go over to yvars, function, and y1. When you run this, you're going to find and you're going to get your y, your a, and your b. Now, if you've turned your diagnostics on, you'll also get some other stuff. So I'll show you how to do that. So if your screen looks like this, you're going to also want to hit second catalog, go to D, go all the way down to diagnostic on, and run that. That way, when you run the test again, or when you run the regression again, sorry, you also get your R squared and your R value. So this is R value is very high. So it's obviously a pretty good fit, but it doesn't tell us all of the story that we need. Um, we can go and look at our plot. I want to do that real quick. So I'm going to turn on my plot and make sure everything looks good here. Okay, so my scatter plot's on, list 1, list 2, all good. I obviously need to go through and set my window. So I'm going to do a zoom and go to zoom stat. So you can see that there's kind of a little curvature to this graph. And that's why looking at residuals is really helpful, because it tells us if there's a pattern to the way that our graph is acting about our least squares regression line. So we first need to go ahead and we need to find what our residuals are, which the residuals are the difference between our first, our predicted value off the line and the actual observation. So I'm going to go to stat and edit. And what I'm going to do here is I'm going to go up and make sure you're highlighted on list 3 here. You're going to highlight list 3 up at the top. So this way you can actually tell it a formula to use. So what I'm going to do here is I'm going to say, okay, well, based off of what it should be at this point, I want you to do y1, or excuse me, our L2 minus what our y1 value would be, which y1 is the prediction of what that should be. Now, all these predictions are pretty close. So I'm going to go to y function y1, and hit enter, and you see that we have this big gap here of all these numbers. Actually, I shouldn't have done that. I got this. Sorry. You want to make sure, apologize, clear that out, redo this, and you're going to do you're going to do L2 minus y1 of L1. So this is going to plug our x column in to our function and subtract that away from L2. So these should be better numbers. Right. So these should be better. Now what you see here is we've got positive numbers here, we've got negative numbers here, and we've got positive numbers at the end. Well, that kind of shows that this is kind of almost like a parabola. So you got positive, and then negative, and then positive again. So that type of residual looking graph is not good for a line. That tells us that some of our data is messed up. So this is all of our residuals here, all in this L3 column. So we can do a residual plot, and that's going to show us some different stuff. So if I go back and I look at my residual plot, I'm going to go back, and instead of my Y list being my actually observed Y values, which is what we have here in this table, it's going to be the L3, and that's going to now plot stuff for me. So let's get rid of that real quick. We are going to now erase our Y1. Actually, we'll leave the Y1 there. But we are going to go back and, excuse me, we're going to go back to zoom, stat. And you can see that our data follows this nice parabola. So this is how we create a residual plot. We're plotting our x value versus the residuals for each data point. So at the beginning, our data points are higher than our line, or higher than our predictions, and then they're lower, and then they're higher. So again, this nice little parabola. That shows that this graph really isn't best represented by a line, but probably a curve. So that's something to keep in mind. Now the second thing that I want you guys to do is try to find the standard deviation of a graph. Now the standard deviation of a graph is going to be a little trickier, and you're going to need, in case I told you wrong, you're going to need to make sure you go ahead and have this line of best fit in your calculator. So I am going to go back into stat, edit, and I'm going to clear out my list 3. Or excuse me, keep the list 3. I'm sorry, I keep messing you guys up. Leave list 3 as it is. So everything should look just like this in your table. So what you need to go ahead and do is the following. You're going to take the square root, okay, of the sum of the squared residuals. Okay, so what you need to do is go and say, you're going to go to second list, over to math, and you're going to go to sum, and then you're going to go, your residuals are in L3, so we're going to do L3, and we're going to square those before we add them up together. So we get that, and then you're going to divide by the number of observations minus 2. Okay, so the sum of these, all these numbers, divided by n minus 2. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Or wait, 2, 4, 6, 8, 10, 12. Yeah, so we got 15 observations. So we're going to divide by 13. If you don't want to count, what you can do is, it's not too hard. You can also do second list and go over to dim, which is the dimensions. That you can do the dimensions of L3 minus 2. Notice the brackets. So if we do it this way, then this will automatically tell you the right number. So if we run this, we get a standard deviation of 1.667. So this is the way that you can go ahead very, very easily and find not only what your line is going to be, what your residuals are going to be, make a residual plot, and find the standard deviation of your data.